Good afternoon. Homework 4B1. We have to find use a Lagrangian to find the maximum values of fx(y) is x plus y squared subject to the constraint x squared plus y squared is 1. A circle. The other one looks like a well, it's a parabola tilted if you rotate x and y. So A is write down the Lagrangian, so that's L of x, y, and semicolon lambda. That's the function itself, so that's x plus y squared minus lambda times the constraint, x squared plus y squared minus 1. Step B is the FOCs. So we need to write down dl dx, the partial derivative of L with respect to x, so that's 1 minus 2 lambda x is 0, call that 1. dl dy is 2y plus, minus 2y lambda, minus 2y lambda, so we can write it as 2y 1 minus lambda, it's 2. So either y is 0 or lambda is 1. Results from is 0, so well, let's put the 0 here. Minus dl the lambda is the constraint itself being 0, which is 3. So solve. C is solve FOCs. So let's look at y is 0 first, so that's this one. And then lambda is 1 is the second case. So y is 0, that's from equation 2, so y is 0 gives us from 3 x is plus or minus 1, and then 2 gives us 2 lambda x is 1, so lambda is 1 over 2x, that is plus or minus half with x is 1. So we have then the points 1, 0, stationary points 1, 0, half, right, and minus 1, 0, minus half. So now we need to do the case lambda is 1. So it's 2 stationary points for one case, so lambda is 1. Well, then from 1, what do we get? Well, 2 is satisfied, so from 1 we get 1 yields x is 1 over 2 lambda is half. And how do we get y? It's half, is that right? So then, what is it? Then from 3, we get y squared is 1 minus 1/4 is 3/4. So y is plus or minus square root of 3 over 2. Yes, so that's then half square root of 3 over 2, 1, and half minus square root of 3 over 2, 1 are the stationary points. F10 is 1, f, we're just finding the maximum now, so it's d by just filling it in, because we don't have the criteria yet to do more. So f1 0, what's the other one? F minus 1 0 is minus 1, so it's obviously it's not a maximum. And f half, well, we can do this one in one go, because we have the y squared, so that's 1/4 plus 3, 1/4, what is it? No, 1/4 is half, plus 3/4 is 5/4. So this latter one, this one gives us the maximum, because 5/4 is more than minus 1, more than 1. So B, B1b. Find the point on the ellipse in the xy is given, closest to and farthest away from the origin. So we need a distance function. Make a sketch of the situation in the xy plane. So fxy is here the distance function. So then it's or the distance function squared. So it's squared, which is d squared. D is distance. And then it's constrained by the ellipse, which is hxy is x squared plus xy plus y squared is 0. So I'm not going to do it all, but you have to calculate the it's 9, it's 9, it's 9. These are circles. So the level sets of circles, and this is ellipse. But this is now x squared plus y squared minus lambda x squared plus xy plus y squared. Step B is the FOCs. Step C is, so you have to write them down. Step C is solve FOCs, and then you have to D is the sketch. So for D, hidden x squared plus y squared is c squared, for various c's are circles. So there will be a minimum circle, a circle with minimum radius, and a circle with maximum radius which touches this ellipse. So oh wait, I'm doing this wrong. So minus 9. So let's see. This is x plus y over 2 squared plus y squared minus y over 4. Y squared over 4 is 9. Is that right? So that's x squared plus xy plus y squared over 4 plus y squared minus y squared over 4, right, is 9. So then this is x plus y over 2 squared plus 3/4 y squared is 9. Well, you can draw some points on the ellipse. Oh, come on, come on, come on. No, no. What happened here? Oh, nightmare. Oh, it hopped. I have no idea where it hopped to. Oh no, I can start. What did it do there? Oh, this is irritating. It hopped to the middle. Oh, this is really irritating. I'll just have to start a new insert page. Oh, what a nightmare stuff, this stuff. Doesn't matter. I was drawing the ellipse. You have the other stuff. Just scroll back. Oh, sorry about that. I don't know why it jumps like that. So we are drawing the ellipse. X squared plus xy plus y squared is 9. So let's draw something. So y is 0, y is 0 is here. So then we have 1, 2, 3, 1, 2, 3. Then we have y is 0. Then we have x is plus or minus 3. So it's here and here. X is 0. X is 0. What do we have? X is 0. Then we have the same. Y is plus or minus 3. So 1, 2, 3. So that's here and 1, 2, minus 3. So that's there. So now let's do y is x. What do we get? Then we get 3x. Y is x. 3x squared is 9. So x is plus or minus square root of 3. So that's on y is x. So y is x. What's plus or minus square root of 3? No, that's 1 over 1. I think it's 1.6, right? We should be able to do that. Square root of 3 is 1.7. So 1.7. So x is 1.7. So then y is x. So that's here. 1.7. X is 1.7. So it's 1.7. Yeah, it's here. So it's y is 1.7. So it's a bit far. It's here. This is roughly here. And then y is minus x gives us x squared. Minus x squared plus x squared is 9. That gives us x is plus or minus 3. So that's on y is minus x. So, oops. That's a bit weird. How does that go? That's here. That's y is minus. No, y is minus x. X is plus 3 gives us y is minus 3. So that's here. 1, 2, 3. 1, 2, 3. And x is minus 3 gives us y is plus 3. So that's right. That's right. Yes. And then it goes through here. Oh, a bad ellipse. Why is it just? Why does it look so weird? Anyway, so it's a bad ellipse. So you have the basically at y is plus x, you have the minimum, and y is minus x. I expect the maximum. Yeah, farthest FI, yes. I mean, my sketch is not very good. Use Desmos to plot things more neatly, but you can do it by hand. That's my point. B1C, where are we? B1C. Use the Lagrangian to find the full in x origin. Compare. Yeah, and now the key is use x, y, z. The target function is distance squared again, but it's a sphere. So there are level sets of spheres of different length, and now you have as set. Now you have as constraint function a plane with normal 4, 2, 1 is 5. So again, A is not very good, but anyway, L, X, Y, Z, lambda is x squared plus y squared plus z squared minus lambda 4x plus 2y plus z, minus 5, minus 5, and then B is the FOCs. Well, Lx is what is it? 2x minus 4 lambda is 0. Y is 2y minus 2 lambda is 0. Lz, call this 1, call this 2, call this 3. L is 2z minus lambda is 0. So again, this gives us lambda is, this gives us lambda is another one and not 0. Another 1, this gives us lambda is another 1, and then you can substitute in 4 and not the LD minus the LD lambda, which is the constraint itself, which is the plane, is 0, so it's 4. So substitute what lambda? I'm doing it wrong. X is 2 lambda. Here y is something expressed in lambda. Z is something expressed in lambda. Substitute this sub into 4. 4. That gives us lambda, whatever it is, and then you substitute back in. You substitute the lambda back in these relationships to get x, y, z, the stationary point. And there is only one, because it will be the sphere which touches that plane. So there's only one. There will only be one stationary point, and you can then calculate the distance by taking that stationary point. So the distance follows, so this x star y star, the distance is x star squared plus y star squared plus z star squared, and then the square root, of course. And you can sketch it to use Desmos 3D to sketch the final case. So then you plot the level set function for distance function. So c squared for the c at the maximum. It is at c, you get c squared, and then c, if you fill in x star squared, y star squared plus z squared to take the sum. Okay, let's look at B2. How does B2 look? Use the method of Lagrange multipliers to solve the following constraint optimization. Check the degenerate. Oh, we should have checked the NDCQs, but anyway. Yeah, but now we have 2. So go back to black. Oh, let's do blue. B2, B2A. We have Lagrangian x, y, what is it, set, and lambda 1, lambda 2, which is x squared plus y plus z minus lambda 1 times, what's the first constraint, x squared plus y squared plus z squared minus 50 minus lambda 2, what is it now, y plus z minus 6. So we write down the FOCs. So the LDX is 2x minus 2x lambda 1. That's it. It's 0. It's 1. The LDY is 1 minus 2y lambda 1 minus lambda 2 is 0. That gives us 2. LZ is 1 minus 2 lambda 1 z minus lambda 2 is 0. It gives us 3. And minus the LD lambda is minus the LD lambda 1 is the constraint, the circle with radius squared 50. 4 minus the LD lambda 2 is y plus z minus 6 is 0, so it's 5. So the first one gives us x is 0, or what is it? Lambda 1 is 1. So let's call this square. Let's call this circle. Let's see if we can first do x is 0. What do we get for x is 0? So we can, since these 2 and 3 both have a lambda 2, so we can subtract them. Then we get rid of the lambda 2. What do we get? And we get rid of the 1. So then we get 2 lambda 1 is y minus z is 0. So this gives us lambda 1 is 0, which we already had, or but we know y is z. It was probably not y. It was probably not wise to first do that. So, well, let's do lambda 1 is 0 then first. Lambda 1 is 0 gives us lambda 2 is 1. It's easy. Wait, that's not true. Lambda 1 is 0. No, lambda 1 is 0 gives us lambda 2 is 1. Because lambda from 2, 3, 2, say. Lambda 1 is 0. And then what do we do next? From 4, 5. From lambda, from 1, of course, we get immediately for lambda 1 is 0, x is 0. And then we can solve 4, 5. So x is 0, so we have we can eliminate 6 set. So we can then eliminate set. Set is what is it? 6 minus y into 4. What do we get? We get y squared plus 36 minus 2y plus y squared minus 50 is 0. So you will have to solve that. What do we get? We get 2y squared. 2y squared minus 2y. What is it? 14, right? Minus 14 is 0, which is y squared minus y minus 7 is 0. Y squared. So you get from that, somewhat ugly, continue here. So y squared minus y minus 7 is 0. I'm doing something wrong. What am I doing wrong? Why? That's why I write 6 minus 12y. Of course, I was about to say minus 12y. So that's minus 12y minus 6y. So that gives us here minus 6y, and this gives us y minus 7. Y plus 1 is 0, so y is 7 and y is minus 1. So that's one set, but we still have to do the case. Let's see the case. Y is set now. So you need to develop the case y is set. So when you can put y is set in 4 and 5. So y is set in 5. Y is set in 5 gives us set is 3. That gives us then y is set is 3. So this is going to be awkward, but y is set in 5 gives us, set is y is 3. Now we have to y set is 3. So that's using 5. We haven't used 4 yet. And we haven't used 1 yet. We haven't used 4 yet, and we haven't used 1 yet. So y set gives us from 5, y and set is 3. Yeah, we have to fill y and z is 3 and 2 and 3. Then we can solve for lambda 1, lambda 2. Once we have lambda 1, we again, oh no, we don't find, if you have lambda 1, it doesn't help. Oh, wait a minute, what am I doing? Y and z is 3, so we can use that, of course, directly in 5. So in 4, y and z, y is z is 3, so that gives us x squared plus y squared plus z squared minus 50 is 0. That's that one. So that gives us x squared plus is 3, 9 plus 9 minus 50 is 0. So x is, what is it, 18 is 32. Is 32. X squared is 32. So x is, what do we get? That is 16 times 2, so that's plus or minus 4 square root of 2. And now you can find, from 1, you can find lambda 1. Well, lambda 1 is, of course, 1, right? Oops. No, lambda 1 for, why is lambda 1? Hey, I'm doing that wrong. This one gives, we shouldn't have read, this is lambda 1, x is 0, lambda 1 is 1. So it gives us lambda 1 is 1, s is there, and then lambda from 2, say we get lambda 2, given lambda 1, we get lambda 2. So from 2, so lambda 2, lambda 1 is 1. This is 3, so that's 1 minus 6 is 5, so lambda 2 is minus 5. Is it right? Minus 5, that's correct. So we get as extra points plus or minus 4 square root of 2, 3, 3, 1 minus 5. So those are the ones. So the NDCQs here now, DCQs at the critical points, so there are 4 critical points. So you need to do gradient of H1, evaluate it at the critical point, gradient of H2, evaluate at the critical points. And we're asked to maximize, yeah, you asked to maximize, so you will have to evaluate at the 4 critical points and see where the maximum is. What's the maximum? Is x squared plus y plus z. So you will have, you get here 2 critical points. You got where we had another 2 critical points. We had another 2, right? Where did we get? We get here critical points, of course. Here we get. Did we solve for x already? Yes, x is 0. So we got 0.7 minus 1 comma 0 comma 1. And we need to, we have x is 0, so what am I saying? For that's for y is 7, and then the other one we have to write down for y is minus 1. So that gives us the 4th critical point. So you need to evaluate that. So then B2B, sorry, a bit sluggish on the Sunday, is well, LXY, is there a set? Yes, there is a set. Lambda 1, lambda 2. lambda 1, lambda 2 is x set plus y set minus lambda 1. What is it? At y squared plus z squared minus 1 minus lambda 2 x set minus 3. What do we do? So now we need to do the FOCs. So actually it's B, this is A. FOCs. So you need to write down 5 times. The LDX is 0 is, the LDY is 0 is, the LDZ is 0 is, minus L lambda 1 minus L lambda 2 is 0, which gives you the 2 constraints, which you already have, y squared plus z squared minus 1, xz minus 3. So here again, I suspect that you can subtract something. So let's do this. This is z minus z lambda 2 is z1 minus lambda 2. So that splits nicely up in z is 0 and lambda 2 is 1. This gives us z minus 2 lambda 1 y, and I think that's it. Yes, so that doesn't give us something nice yet. That's 2. The LD set is x plus y minus 2 lambda 1 z minus lambda 2 x is 0. That's a big one, minus lambda 2x, yes. So that's, this is 4, this is 5. So so this 1 gives us z is 0, 0, but that can't be. Violates 3, violates 5, because then we would get 0 and it's unequal to 3, so that can't be. So this one is eliminated. We only have what is it? Lambda 2 is 2. So lambda 2 is, what do I say? Lambda 2 is 1. Lambda 2 is 1 is the only case which remains. So that solves 1. Lambda 2 is 1. The lambda 2 is 1 is nice, because then the x and the minus lambda 2x cancel. So lambda 2 is 1. Let's fill that in. Then we have z minus 2 lambda minus 2 lambda 1 y is 0, and y minus 2 lambda 1 z is 0. That's a nice structure, because now you can subtract these. So you subtract these, what you get, you add and subtract. Let's see. We can get we can say 2 lambda 1 is set over y, that's right, but also is y over z, and that gives us y squared is z squared, which gives us y is plus or minus z, and then you develop y is z or y is minus z. So you develop both cases, and each give you different critical points. So you have to develop that. It gives you a whole series of points which you then have to develop. So for so for y is set, for example, you can solve for lambda 1, and for y is minus using 2, and for y is set minus set, you can, for y is plus and minus set, you can solve for lambda 1. Once you have lambda 1, you can use you can use 5 to express x as 3 over z, and then substitute that into 3 to further develop it. But I'll leave that to you, and you can look up the final solution or see if your final solution works out. At least you can now get going. All right, that was it for this Sunday. Good luck. Oops, did I? Yeah, here. So yeah, so you develop. I didn't see that. You develop the case lambda 2 is 1. You eliminate. You write out lambda 1, and then you get y squared is z squared, which you develop in y is z and y is minus z. And then you continue to solve all 5 FOCs. That's important. You need to solve them all 5.